Question number 8. Tan theta equals 5.345 and is in quadrant 3. And it asks, what are the trig ratios for sine theta and cos theta? And secondly, it says, what's the possible value for point P that defines the terminal arm of theta? So I've drawn the picture here of theta in quadrant 3. So it has a tan ratio of 5.345. So in order for that to happen, we need to have this coordinate here, that we need to have it in ratio of negative and negative. So to work out the sine ratio, we need to work out the length of the hypotenuse. So we use Pythagoras. So we use 1 squared plus 5.345 squared, and then we square root it, and we get this length of 5.4, looks like 377, so I'm going to round that to 38. So there is my hypotenuse, so I can define my sine theta. My sine theta is going to be my vertical, so negative 5.345 divided by 5.438, and that ratio is going to work out to be that ratio works out to be looks like 5.345 works out to be about 0.9829, so I'm going to round that to 3. The cosine is going to be based on the x coordinate, so cosine theta is going to be equal to negative 1 over, sorry, that's going to be negative here, negative 1 over 5.438. So when I do negative 1 divided by that, we get approximately negative 0.1838. So I'm going to round that to 184. So those are my sine and cosine ratios. Now, when we talk about standard positioning, this could actually be, the sine and cosine ratios can actually represent x and y coordinates of a radius 1 circle. So if I draw the same position with a radius of 1, this length here is going to be negative, or the position is going to be negative 1.184, and the y position is going to be negative 0.983. So that's a possibility, but we can have all sorts of multiples of that. So it could also be using the position on the bigger circle. So negative 1, 5.345, and that would also be a possibility. So any multiples, we can scale this any way we want, but as long as it's in that ratio, we'll have possible coordinates for point P on the terminal arm.